nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. It simply means that exactly there is some nums such that number of elements greater than or equal to x is x. Number of elements which is greater than or equal to x, that number is x, and it's also greater than that number of elements. We'll see by example also. And again, they are saying that notice that x does not have to be an element in nums. So there's not, it's not important for x to be in nums. For example, in this answer is 2. There are 2 elements in nums which are greater than 2, right? Thus the answer is 2. Here there is no element in nums which is greater than same value. So answer is -1. Here I have 3 elements in nums which are greater than or equal to 3. As you can see, 1, 2 and 3. 3 elements which are greater than or equal to 3. I have to figure out x, which is that element which is greater than or equal to that number of elements. Now, very basic stuff is, for example, if I just write this exact same stuff, you will ask yourself, Aryan, okay, I know one thing for sure, that I want to try and see the number of elements greater than or equal to some specific value. And I know the more value I will include, the more numbers will keep on coming in. For example, what I mean by this is that, okay, let's imagine I have only first element. I look at the first element. Again, I'm asking you, as a person, I'm asking you, shall I iterate from left or right? You will say, Aryan, how does it even matter? Array is not even sorted. Okay, what if I sort the array? Then shall I iterate from the left or right? Then you will say, okay, if I iterate from the left, it will give me 3. What does it even indicate? For me, I am saying I went on to first element, which means I have got 1 element. So for me, again, the count, the number of elements is increasing. For me, I have got 1 element. So technically, I should say number of elements greater than or equal to 1. Is it 1? Who knows? Then you will try to say, okay, let's try to go forward. Okay, I'll try to go forward. Number of elements greater than or equal to 2 are what? Like, if you go forward, will you not include it or will you include it? Like, what's happening? Okay, that's again, this is just, we are discussing. Again, in the approaches, we just discussed what things can happen or what you are thinking right now. Okay, let's try from the end. I went on the first element. Again, I will say the count is 1. Number of elements greater than or equal to 1 is 1. But I can also try to look for the next element. Maybe what if he was 1? Again, right? Maybe what if he was 1? So I will try to look for the next element. And I will say, okay, before even incrementing my count to 2, I will first check, okay, I will check that if this element is same, or maybe here in this case, you remembered it was a 3. So, okay, my count is less than my 3, which means, okay, I can easily increment my count, and I should ideally increment my count because I have gone to next element. But you see how it is a bit tricky that you have to also check the previous number, right? Again, as we go on forward, and then I saw, okay, it is 2, and for sure, it is less than my number. So I'm good. Then I will try to go more next. And I will see if I have the number of elements which are maybe less. So I will try, okay, array is ended. So I have got a 2, and total number of elements I also had was 2. So I'm good. Again, I told you the first approach is the most tricky or the most hardest, but also the most intuitive. Then I will maybe try for the first one. I will say that the count is right now 1. Again, the array is sorted. So this is the largest element. On the right side, I have the largest element. Array is sorted. I have the largest element. So ideally, if I have a count of 1, so I should have at least 1 element which is more than equal to 1. But I got a value of 0, which is less than 1. For sure, return a -1. So as soon as my count becomes more than my nums of I, I should ideally return a -1. That's one condition. Here I can simply see that I will check if my nums of I is more than equal to my count, then I can maybe increase my count. But you saw one thing also, that firstly, I will also check on the next place. I'll show you with the example also. Now, in this case also, for example, here I will have in the very beginning count as 1, okay, value as 4. I will try to increase my count. Okay, count is 2, value is 4. Okay, increase my count. Count is 3, value is 3. Again, increase your count. Why are you increasing your count? What if he was 3? Got it? Because again, right now you have ended here. Number of elements greater than equal to 3 are 3. But what if 3 would also have been here? Then you should, no matter what, you cannot just stop here. You have to try and cover all the numbers which are greater than equal to this count, right? So I will have to firstly go and come here. If it is same, or maybe he is actually more or less whatsoever it is, I have to check. Oh, if again in our case it was a 0, so if I even increase it, I should stop, and I have already got my answer here itself. Answer is 3. So okay, last example here. This will clarify everything. Okay, in the very beginning my count is 1. Number of elements greater than 1, okay, 1. Number of elements greater than 2, 2. Number of elements greater than 3, 3. Again, although I have 3 here, I cannot stop. I should check. I will again, as the count is 3, so I have to make sure number of elements which are greater than 3, I should go all such previous elements, and I can see that 3 is also there. So ideally, before even going back, I will not directly increase it. I will not make it as a 4. Nah, which if I increase it at a 4, it will say, okay, number of elements, you are trying to search for number of elements which are more than 4, but here is 3. So you might end up breaking the loop, but you cannot break the loop right now. You shift it directly, compare if it is same. Oh, it is same, which means this will increase to 4. Number of elements greater than equal to 3 are 4. Sorry, bro. The condition violated. Number of elements, which means your count has become equal more than your number of nums of 5, which means it's a violation. Sorry. Yeah, it's a violation. So you have to kind of return a -1. So whenever you get a violation, when again, you get a violation only when you try to check if nums of I was more than equal to your count. Here nums of I was more than equal to your count, then only you try to increase your count. You try to increase your count, and then you check, oh bhai, the count has become more than your nums of I, so simply have a -1. And for sure, else in this case, like in the above case, as you can see, when you even increase it, it still is actually more, then you can simply say, bro, before even again, here you check, here you remember, I firstly keep the count as it is, then compare it. If my count is actually less than or equal to nums of I, then only I increase my count. Here in this case, my count is more, so I will end up in the else condition. And if the count is still 3, I should simply return a count itself, which is 3. That is the code. Again, this is the most tricky code, most hardest part. The other approaches are very easy, but this is the most intuitive also. But people usually end up thinking of it, but not implementing it. So firstly, we'll get a count, we'll get a I, and then again, this is not required. So we'll get an N. Then we go into all the elements. If my nums of I is more than equal to my count, then again, I did not increase my count, right? I started with my count as 0. I firstly check. If it is, then I increment it, and if it violates, then I put a -1. And else, okay, I can put a count as an answer. Ultimately, as you remembered in the final case, in the final answer, when you have a 5 and 3, you might end up reaching the very end. If you reach the very end, you already have all the numbers which are more than equal to n. So your answer is n itself. For this, you sorted the input array. Again, I sorted in the descending order so as to incorporate that moving from end logic. But you can just do it from the beginning also. But you will see the complexity. Again, I'd modified the input array. That's not optimal. So you can take at, like, you can imagine as I made a copy of nums and then sorted it. So I should add an extra space of O of n just because I'm thinking I will make a copy of it, right? This is for sorting space. This is for sorting, and this is to iterate on the entire array from the end. Now, one very basic thing which we saw, that what we have to find out is number of elements greater than or equal to x, right? So for sure, if I just ask you number, again, take any example, take this input array, number of elements, again, number of elements greater than, if I ask you number of elements greater than 1, again, firstly, what is a possible answer? Number of elements can be greater than 1, 2, 3, 4 or 5. I cannot ask number of elements greater than equal to 6. Why? Because number of elements greater than equal to 6, I need it to be equal to 6 only, but I only have 5 elements, right? So for sure, my input search itself will say number of elements greater than or equal to something. That something can be from 1 to n, right? Okay, so in this case in this example itself, let's say I ask number of elements greater than or equal to 1. You will say, Aryan, there are only 3 elements. Okay, I'll say 3 elements. Number of elements greater than or equal to 2. Again, I have 3 elements. Okay, again 3 elements. Number of elements greater than or equal to 3. Again, I have 3 elements. Okay, 3 elements. Number of elements greater than or equal to 4. I have 2 elements. Okay, 2 elements. Number of elements greater than or equal to 5. I have 0 elements. I have 0 elements. So you see that this is always decreasing. This is always decreasing. And that's obvious also. Because you are increasing the elements, so number of elements greater than them will decrease. What this shows. Simply, I can apply a binary search. Now I know I have to firstly find that number. Again, this is decreasing. So I have to find that number which is equal to that. Again, I will do a binary search and I just have to find some equal pair where these are equal. And that is exactly what I want. What I will simply do, I'll take this exact same example. This example, let's say, again, in this, I will firstly build this entire stuff. That okay, number of elements greater than or equal to 1, 2, 3, 4, 5, and so on and so forth. And that you can easily, this also you can easily find out. There are 2 ways to find out. Either you can do a count, which means again, you remember, like you figure out that you will simply do a binary search. And you will find out the value of x, right? Number of elements greater than or equal to this. But then I showed you that you will either store this, that okay, number of elements greater than or equal to 2. How will you find? Again, I'm doing a binary search on this portion. Number of elements greater than or equal to 2. I'm trying to find. And if it comes out to be something, oh, it is high. It is high. So I should ideally, if it is high, I should ideally move to my light. Like I should increase my L. And again, let's say if my binary search reaches here, it is less. I'm doing a binary search on my left side. I received the count frequency of elements greater than or equal to 4 as 2, which is less than my left side. So I should ideally go up. This is how I can simply go up and down. So you see, there's a 2-way binary search which can work. But for simplicity, I will show you 2 ways in this binary search only. So you figure out that, okay, I will do a binary search on this left portion. And I will say number of elements greater than or equal to 2. Now, one way to find out this frequency is to iterate on this entire array. So I can do, I'm doing binary search on this left portion. I will ask number of elements greater than or equal to 2. So you will go on to the input array and you will iterate on this and ask, are you greater? Are you greater? Are you greater? Oh yeah, you are. So count increase by 1. Are you greater? Yeah, you are. Count increase by 2. Oh, like 1. So it became a 2. Are you greater? Yeah, you are. Count increased. It increased to 3. So number of elements greater than or equal to 2 are 3. That's one way. Again, for this, the array need not to be sorted. But if you want to get to know this count fast, what you can do? You can simply sort this input array, sort this, and then do a lower bound on 2. Do a lower bound on 2. Thus, if you do a lower bound on 2, you will land onto this index. This will say that all the elements are greater than or equal to 2 on the right side. So if this index is S, if the last index is E, number of elements greater than or equal to 2 will be E minus S. So you figure out it's a binary search on the left portion. Then to figure out the frequency, either I can do a linear search, or if I sort the input array, I can figure out the frequency also by doing a binary search or a lower bound. So it is a 2 binary search in the same problem, right? And that's how I can simply get the frequency. So if you don't know binary search, if you are confused about all that, just one video, one template, more than enough to explain everything. So the code looks exactly same as we have seen in this template, that we know that input ranges, we know the input range is L and R as 1 to N. I showed you why, because I know X can be 1, X can be N, that's it. Then the simple binary search template, simple template, again, simple template. Again, this is also simple, exactly same template which we have been using. Now I told you, I'm doing a binary search on my left portion. left portion says that number of elements greater than equal to mid or x. I will find the number of elements greater than equal. Again, this is the binary search by itself on left portion. But then to find the frequency or the size, which is of the right portion, this is the right portion, which was on the right. I am again using a binary search, which is a lower bound. You can also write your own binary function. It's up to you. But I was like, okay, let's write one liner. I use the inbuilt function, which is the lower bound, to get number of elements greater than or equal to mid, which is x in this case. Now, if I have got equal, okay, if it is equal, then for sure I have got the answer and I should try. Again, this is not required. I can simply return my answer from here. Return answer. That's it. If not, again, this is not required. I'm again telling, right? This is not required. Just return the mid. Return the mid or size. But usually in the template, you will see, which we have discussed, where it is gone. Okay. In this template, you will see that we have discussed that we store answer and then return the answer. For simplicity, it will help you in other problems also. But yeah, that's not required. You can just simply skip it and that will work. Now, what again, make sure that other conditions are satisfied. If your size, right side, again, this is the right side portion, which is the frequency of elements. If the frequency of element, it is more than my left side, so I should go down. If the frequency is less than my left side, I should go up, right? Down means simply if the size, it is more than my left side, size is more than my left, which is mid, I should go down, increase my L. If it is less, I should go up, decrease my right. And that's how I can simply do a binary search. Now, simply if you do a sort n log n time, binary search on left portion log n, for corresponding every portion in the left, you will have to do binary search on the right, like right portion, which means to get the frequency, again a log n. So it is a log n square. And again, space log n for sorting, and n because of I will make a copy of nums because I'm sorting my nums. Now, last approach, easiest one. It is inspired from the first approach that we were kind of maintaining. Again, if you remember the issue, the complexity in the code in the first approach was that if I am here at 1, okay, I was saying, okay, 2, I was saying 3. Now, here it was tricky. I cannot stop here at 3. I have to go and check for all the elements that are greater than or equal to 3, which means he should also be considered. So for that, we found out a hack that we were actually like checking the same number, which is 3, and then if it is, then only we were incrementing it. Now, to just handle this entire case, we know that the answer can be from 1 to n only. So I made a bucket which will maintain the frequency of the elements. So you will see 3 frequency is 1, 4 frequency is 2. Same way, here you will see that 3 frequency is 1, but 6, 7 and 7, their frequency I have put as 5 because I know the maximum answer can be 5. So they, like, the highest number should incorporate these values. Now I will now iterate from the end, same way I was doing earlier, right? Iterate from the end. But now it is very simple. All the numbers which are greater than or equal to 5 are actually clubbed at this location only. All the numbers which are greater than or equal to 5 are clubbed at this location. All the numbers greater than or equal to 4 are at this location. All the numbers greater than or equal to 3 will be the suffix sum of this. All the numbers greater than or equal to 3 will be the suffix sum of this. Now, same way, all the numbers greater than or equal to 2 will be this. Again, this is also the suffix sum. Same way, all the numbers greater than or equal to 1, suffix sum. So again, I will just simply iterate. All the numbers greater than or equal to 2 are just 2. Got the answer. All the numbers greater than or equal to 2, 0. No number, bro. -1. All the numbers, again, I can simply iterate, and again, I can just put a -1 in the end also. That okay, I just iterate. Okay, all the numbers greater than or equal to 0 are 2. Like, you can simply iterate and simply get back. Here you can simply see all the numbers greater than or equal to 2. Sorry, greater than or equal to 4. are 2. All the numbers greater than equal to 3 are 3. Again, the sum, suffix sum. All the numbers greater than equal to 5 are 3. Okay. All the numbers greater than equal to 3 are 4. I never received my answer, which means my count, which is the suffix sum, is my count. It never matched with my any of the indexes. It's a -1. So I'll do the same stuff, that I will maintain the frequency, same vector. Again, I have put a minimum, you know why. Then I went on from the back. I kept on maintaining the suffix sum count. If it matches at any point, I'm good to say I got the answer. If not, at any point, if it doesn't match, -1. And that's how this will give you a O of n time complexity, because you are just using a O of n size array and O of n space array. And that's your space time as O of n. Cool. I know the first approach was a bit, again, it's easy to think, it's most intuitive to think also, but it's a bit tricky to implement, because you have to check when to increase count. It should be increased post checking. First move, then check, then increase. If it violates, then break. Cool. I hope you guys got it. If yes, then please just smash the like button. And yeah, see you in the next video. Goodbye. Take care. See you guys in the next video. Until then, goodbye. Take care. Bye. Like, that's a long time I'm saying that. But bye. Cool. Bye bye.